Production of growth hormone is modulated by many factors, including the stress, exercise, nutrition, and the sleep. However, the three primary controllers of the main node are the two hypothalamic hormones, GHRH and somatostatin, and one hormone from the stomach, ghrelin. GH itself and IGF-1 also affect in a negative feedback loop. Let us look at their feedback loops visually so it is better to understand. So we have hypothalamus, the pituitary gland, stomach, and the liver. The hypothalamus releases two hormones as discussed, the GHRH, which has a positive effect, and the somatostatin, which inhibits the growth hormone release in response to GHRH and to other stimulatory factors such as low blood glucose concentration. Then from the stomach, we have the ghrelin, which also stimulates the GH production. Growth hormone secretion is also part of a negative feedback loop involving IGF-1 from the liver. High blood levels of IGF-1 lead to the decreased secretion of growth hormone not only by directly suppressing the somatotrophs but by stimulating the release of somatostatin from the hypothalamus. Growth hormone also feedbacks to inhibit GHRH secretion and probably has a direct inhibitory effect on secretion from the somatotrophs. It is important to note that any dysregulation in this whole loop may lead to disease condition in the patient. This mostly occurs if even one of the organs in this loop is damaged, maybe due to a tumor or a lesion. Now, keeping in the mind that the growth hormones plays an important role in the growth and metabolism, so the excess secretion due to the tumors in the pituitary may lead to gigantism and acromegaly. This excess release will also have an effect on IGF-1 production, leading to a number of metabolic derangements, including hyperglycemia. Because the metabolic action of growth hormone are antagonistic to those of insulin, some of the patients with acromegaly develop diabetes mellitus. In the opposite direction, a deficiency state can result not only from a deficiency in the production of the hormone, but in the target cell's response to the hormone. It results primarily from the damage to the hypothalamus or to the pituitary gland during fetal development, that is the congenital GH deficiency, or following the birth, that is the acquired GH deficiency. So the deficiency in the growth hormone leads to the stunted growth and may lead to dwarfism. Now you know the normal physiological effect of growth hormone on your body. In order to learn about the physiological effects of other hormones, stay tuned to sqadia.com.